Welcome to The Explainer. Today, we're going to talk about something pretty incredible, your body's own personal energy pantry. Yeah, it's the secret system that keeps you running on all cylinders, even hours after you've eaten.
Okay, so let's start with a question. Have you ever really thought about this? Your brain needs a ton of energy, like all the time, 24/7, but you only eat, what, a few times a day? So how does your body solve that problem? How does it keep the lights on in between meals?
All right, let's really get into it. This is the core problem, right? Our bodies are in this constant battle. We have this nonstop demand for energy, but the supply, well, that only comes in spurts whenever we decide to eat.
And get this, the biggest energy hog in your whole body is your brain. I mean, it's just chewing through a whopping 75% of the glucose you use every single day. It's super demanding, and it doesn't care if you just had a big lunch or if you're fasting. It needs its fuel, period.
So nature came up with a really brilliant solution. It's a molecule called glycogen. You can think of it as your body's built-in smart storage system, a quick-access energy reserve that's ready to go at a moment's notice. So what is this stuff? Well, glycogen is basically just a bunch of glucose, sugar, all packed together. But the way it's packed is genius. It's this huge branching molecule, kind of like a tree with tons and tons of tiny branches. This structure lets you cram a lot of energy into a small space, and this is the really cool part, it means you have thousands of little ends to grab glucose from, making it super fast to access. Okay, now this is where it gets really interesting. We don't just have one of these energy pantries, we've got two, and they have completely different personalities. First, you've got the liver pantry. Think of it as the generous one. Its job is to share its stored glucose with the whole body, especially that greedy brain, to keep your blood sugar nice and stable. Then you have the muscle pantry, and this one, well, it's selfish. It hoards all its glycogen for itself. It doesn't share with anyone. It's saving it all for when the muscles need a big burst of energy for exercise.
All right, so we've got these pantries. How do we actually stock the shelves? The process is called glycogenesis, and it really kicks off right after you eat a meal, especially one with carbs. Your body detects all that incoming glucose from your food, and it's like, okay, time to store the leftovers for later.
And the main signal for this whole operation is insulin. When you eat and your blood sugar goes up, insulin is released, and it basically shouts out to your liver and muscle cells, all right, people, we're flush with energy. Time to go into store mode and pack this stuff away.
Okay, don't get bogged down by the chemistry here. The process itself is what's important. It's basically a three-step assembly line. First, the glucose molecule gets activated. Then, a builder enzyme, glycogen synthase, starts linking them together. Finally, another enzyme comes along and creates all those branches. That's the key to making it so compact and easy to access later on. But, stocking the pantry is only half the job. What happens when it's been a while since you've eaten, or you need to suddenly run for the bus? Your body has to be able to raid that pantry and fast. This is when we switch from store mode to use mode.
And for that, we have a different set of signals. Two hormones, glucagon and epinephrine, are like the alarm bells. Glucagon goes off when your blood sugar gets too low. Epinephrine, you probably know it as adrenaline, is for that fight or flight response. Both of them send the same urgent message, we need energy, and we need it now.
So, this breakdown process, called glycogenolysis, is pretty much the reverse of building it. This time, a breaker enzyme, glycogen phosphorylase, jumps into action. It just starts rapidly snipping off those glucose units from all the branch ends, releasing a flood of ready-to-use fuel.
Now, this is so important. These two processes, building up and breaking down, don't happen at the same time. That would be a total waste of energy, right? Your body is way too smart for that. It's a one-way street. You're either storing or you're using, never both.
And this is how it pulls it off. Those hormones we talked about, they're the master switches. When insulin is high, it turns on the builder enzyme and turns off the breaker enzyme. It's store mode. But when glucagon or epinephrine show up, they do the exact opposite. They turn off the builder and turn on the breaker. Use mode. It's a beautifully simple on-off system that makes sure energy traffic is only flowing one way.
It's an amazing system when it works. But what happens when it breaks? Well, that's what leads to a group of rare genetic conditions called glycogen storage diseases. In these cases, one of those crucial enzymes, like the builder or the breaker, just doesn't work right.
And looking at a couple of these really shows you why those two different pantries are so important. Take von Gierke disease. Here, the generous liver pantry is broken. It can store glycogen, but it can't release it. The result? The whole body suffers from dangerously low blood sugar between meals. Now compare that to myocardial disease. Here, the selfish muscle pantry is the problem. The muscles can't tap into their own fuel stash. So, what happens? People get extreme pain and fatigue when they try to exercise, even though their overall blood sugar might be totally fine.
So let's just quickly pull all this together. What have we learned? Glycogen is your body's go-to quick access energy reserve. You've got the generous liver taking care of everyone, and the selfish muscles just looking out for themselves. And the whole thing is controlled by these hormonal master switches, insulin for storing, glucagon for using. It's this beautiful, constant balancing act that is literally essential for keeping you alive and moving every single second.
I mean, it's just incredible, isn't it? This whole complex dance of storing and releasing energy is happening inside you right now, without you even having to think about it. It really makes you stop and wonder, what other amazing, invisible things is your body pulling off right now, completely behind the scenes?